learners, welcome to today's Grade 10 Math Show. Today we have a special revision lesson on number patterns, equations, and inequalities. We have selected highlights of lessons shown earlier in the term to help you revise Term 1's work. Please post all your questions and comments on our Facebook page on facebook.com/LearnExtra or on Twitter @LearnExtra so we can help you with your revision. Don't forget to download today's show notes on learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with our lesson.
Okay, so question 1, we are asked to determine the general term of the following sequence. Now guys, in grade 10, you're going to mainly be limited to arithmetic and linear sequences. As you go on, it's not going to just be limited to arithmetic and linear sequences. So you can't always assume that a sequence is linear. You need to check and see that there is a common difference between the terms. So in this question, they just give you that this is a sequence. They don't tell you what kind of sequence it is. The first thing you need to do is to test and see what kind of sequence it is. All right. So we've got the term 6, 12, 18. We know nothing else about the sequence. The first thing we need to do is determine if it's arithmetic. How do we know if it's arithmetic? Well, term 3 minus term 2 must give us the same answer as term 2 minus term 1. So there's got to be a constant first difference. Term 3, 18 minus 12 is equal to 6. And then term 2 minus term 1, we've got 12 minus 6, and that's also equal to 6. So therefore, we've got a common difference of 6. So therefore, this sequence is arithmetic. All right, the formula we're going to use, because now we've identified that this is indeed an arithmetic sequence, so that straight away gets us thinking about this formula. Tn is equal to A plus n minus 1 times D, where D is your common difference and A represents your first term. Now to tackle the question. So we've determined that it's arithmetic. We've worked out the common difference. They say find the general term or the nth term of the sequence and then find term 25. In order to find term 25, we first need to work out the nth term. You have to have your general term, because remember, your general term will help you to find any term in the sequence. Okay. How do we work out this general term? Well, we go to this. We go to that formula there. We know that A represents the first term, and D we know is equal to 6. So we simply plug in the values that we have. In our given sequence, we know that A, our first term, A, our first term is actually equal to 6. So therefore, I've got A is equal to 6. I can put that in. And in my formula, I'm going to get Tn is equal to 6. I replace A with 6 plus n minus 1 times my difference D, which is also 6. Okay, we then times everything out, and let's see what we get. So we're going to get 6 plus 6n minus 6, and that just gives us an answer of 6n. So Tn is equal to 6n. In other words, these are all the multiples of 6. Always, okay, this one, it's pretty straightforward to see that the formula works, but always when you get your answer for your general term, just check a few terms and see that it actually works, because it will straight away, if you've made a mistake with some of the algebra and the arithmetic in between, it won't work out if you've got the wrong general term. So remember, we can check any term. So if Tn is equal to 6n, right, and I want to see that if I put 3 in, for example, I need to get an answer of 18. So if I do that, I'm going to say T3, replace n with 3, is 6 times 3, which is 18. So therefore, I have checked. This check is just for yourself. It's not for any marks. It's just will prevent you from losing any marks, because obviously if you make a mistake here, you're going to pick it up immediately. So we check it, we see, okay, it works out. Term 3 is in fact 18. The formula works out. All right. Now that we've got the general term Tn, they've asked us to find term 25. Okay, this board seems to be skipping a little bit, but there we go. Now we want to find term 25. Guys, remember, to find any term, we substitute the value of the position of the term in place of n. So term 25 is going to be 6, and in place of n, I put in 25, and I get 6 times 25 gives me 150. Okay, so therefore term 25 is 150. And you'll agree that having the general formula or the nth term makes life much, much easier, because you can't just sit and add on 6 and 6 and 6 and 6 until you get to term 25. You just don't have time for that. So you need to have this general term, because it does make life much, much easier to find any term in the sequence and to find the position of any term in the sequence. All right, so that's our first basic example, just getting you guys back into thinking about arithmetic sequences using the formula that I have given you. So we're going to go into another one where it's sometimes everyone's worst, is where you put math in words. Everyone seems to get confused with that, but we're just going to sift out. Remember, when you see any kind of word kind of problem, whether it be in number patterns or equations later on, you really just need to convert it to mathematical logical steps, okay, and take it from there. So try and convert the words into something that makes sense mathematically. So this is question 2 with a few words in it. All right. They say that you want to start saving money in your piggy bank, but you've never tried to save money before, so you want to start slowly. At the end of the first week, you save 5 Rand. Then at the end of the second week, you save 10 Rand. And at the end of the third week, you save 15 Rand. They want to know, in which week will you save 50 Rand? So it might look a little bit confusing at first, guys, but we're going to break it down into something that makes a little bit more sense. And I'm going to put a table in. You don't need one, but I'm going to put it in anyway, just because I want to show you where we're going to go with this. Okay, I'm going to put N to represent the weeks, and then this is going to be the amount saved. Okay, in week 1, they tell you that you've saved 5 Rand. In week 2, you save 10 Rand. And in week 3, you save 15 Rand. They want to know, in which week will you save 50 Rand? So they're telling you this is going to go on and on and on. At some point, you're going to get to 50 Rand. And they want to know, when is that going to happen? So what are they looking for? They're looking for the position. They're looking for the week in which you are going to get this 50 Rand that you're going to take and put it into your piggy bank. All right. So which week are you going to get to 50 Rand? In other words, they're looking for N. Okay. How do we do this? Okay, at the moment we've just got numbers. We've got to turn it into something that makes sense mathematically. That means using number patterns, we need to form an arithmetic general formula. Okay, so from what I've got, I know that the formula I'm going to be using depends on whether this is arithmetic. All right, so we test it. We say term 3 minus term 2, and I get an answer of 15 minus 10 is 5. And then if I say term 2 minus term 1, I get an answer of 10 minus 5, which is also 5. So therefore, we've got a common difference equal to 5. Okay. When you use that formula, Tn is equal to A plus n minus 1 times D. Okay, let's see if I can get that to the bottom. So if we're using Tn is equal to A plus n minus 1 times D, in order for this formula to work out, for me to get a general term out of it, I need A and I need D. So the first term, A, we know is equal to 5 because you save 5 rand in the first week, plus n minus 1 times D, your difference each week is 5 rand. You put 5 rand more in every week. So therefore, working my formula out, I'm going to get 5 plus n minus 1 plus 5n, sorry, minus 5, and I end up with 5n. Okay, so my general term here is Tn is equal to 5n. Now that I have this general term, we can find, because remember what they've told you is they've said in which week will your general term, but that's not how they said it, hey, they said in which week will you save 50 rand. So in other words, what they're asking you is in which week will your general term be equal to 50. So when is your nth term going to give you an answer of 50? We know that Tn is going to be 50 in some week, but we also know that Tn is equal to 5n. So therefore I can say 5n is equal to 50, divide through by 5, and I get that n is equal to 10. So in terms of writing this down as a proper word answer, really, we can say therefore you will save 50 rand in the 10th week. Okay, so this was an example where we had to first work out the general term, and then from that general term work out the position that we will get an answer of 50. Okay, so you can obviously see how important the whole general term and working out, understanding how to work out a general term from arithmetic sequences is. Okay, so far we've had a look at a basic example, reminding you guys how to find A, how to find D, how to use all of that information to work out your arithmetic general formula. And we've then looked at a little word sum that you could get in number patterns. And the next thing we're going to do, which you can also get, is you're given a diagram. And the diagram just has a whole lot of things given, a whole lot of information, a whole lot of squares, cubes, whatever it is. And then they ask you questions about that. So it's another typical type of question you can get. So this is question 3. All right, so here we're looking at a pattern of hexagons. Okay. And they're asking us to determine how many hexagons there will be in the 10th pattern. Okay, so let's see what we've got here. The first thing we need to do is determine whether it is an arithmetic sequence, because we don't really know anything about it yet, right? So in my first pattern of hexagons, I see that I've just got one, right? We've got one hexagon there. Then in the second one, we're going to count the number of little hexagons and see how many we have. We've got 1, 2, 3, 4, 5, 6, 7. We've got 7. Okay? And then in the third pattern, we know this bottom bit is going to be 7 because it's the one I've just counted. 7, 8, 9, 10, 11, 12, 13. Okay? So we've got this pattern, 1, 7, 13. First thing we need to determine is it arithmetic? How do we determine that? We say term 3 minus term 2. So 13 minus 7. And I get an answer of 6. And then if I say term 2 minus term 1, I get an answer of 7 minus 1, which is 6. So therefore, I have a common difference of 6. Okay. Now, what is it that they're asking us to do? They're saying how many. So we know that eventually this pattern is going to continue itself all the way to pattern 10. So they want to know, in that pattern 10, how many of these little hexagons do you expect to have in pattern 10? In order to work this out, what do we need? We go back to the same thing again. We need to be able to work out the general term. Once we have the general term, we then substitute the number that we're looking for, the position. We know we're looking for what's happening in pattern 10, so we substitute the n with the 10, and that will help us to work out how many hexagons in the 10th pattern. All right. Hopefully you guys can see the pattern that's developing within these number patterns, right? It's a pretty similar method in each and every one. We're going to use Tn is equal to a plus n minus 1d. We know that a is equal to 1 because we had just one hexagon in the first pattern. And we know that d is equal to 6. So we substitute 6 in place of d, and we get 1 plus 6n minus 6. And that gives us an answer of 6n minus 5. Remember, guys, just test it to see if it works. So, for example, we know that pattern 2 had 7 hexagons. So this is a general term we're saying is correct. Let's test it. So if I substitute 2 in place of n, I'm going to get 6 times 2 minus 5. So I get 12 minus 5, which is 7, and that is indeed correct because we had 7 hexagons in pattern 2. And let's see if I can get back up there, if this page will play along. There we go. So we did have 7 hexagons in pattern 2, so we know that the formula that we've now developed for the sequence is in fact correct. Now that we have this general formula, we can use that to say how many hexagons there will be in the 10th pattern. All we're going to do is, we know that we're looking when n is equal to 10, we're looking at what's going to happen. So my formula Tn is equal to 6n minus 5. I want to find out how many hexagons in pattern 10. I substitute 10 in place of n. Alright, and I get 6 times 10 is 60. 60 minus 5 is 55. Okay, so therefore what we're saying is that in the 10th pattern, if this pattern continues, in the 10th pattern, there will be 55 hexagons in that pattern.
Alright, Mindsetters, I hope you guys are enjoying this revision session. Remember, if you are struggling and need help, please post your question on our Facebook page or send an email to helpdesk@learnextra.co.za. Now it's time to take a quick break, so don't go anywhere. We'll be right back. Welcome back, guys. I'm sure you've seen and heard about the Mindset Rack nomination and hope you'll get involved. If you make a video, post it on YouTube with the title #LearnExtraRack followed by your name or the name of your group. If you don't have a video, post a photo on our Facebook page and tell us what you've done. Let's use this short holiday to make a big difference in other people's lives. Now, let's get back to revision.
All right. So we've got to solve for x here, and as you can see, we've got a fractional equation. It's 2x plus 1 over x plus 2x over 2x minus 1 is equal to 3. So the first thing I like to do before we actually get into the whole equation is to put a restriction on my denominators, because guys, remember, you cannot divide by naught. That's undefined. Okay, so we first have to set ourselves up restrictions, because remember, we don't know what x is. X can stand for any number at all. So in the end, when I get my answers for x, I need to compare those values of x to the restrictions and see if there's no conflict. Okay, so firstly, if we've got x in the denominator here in the first term, what value for x would make the denominator naught? Well, the only value that could make x naught there is if x itself is naught. Okay, because then you're basically just dividing by 0, and that will be undefined. So x cannot equal naught. Now, if you look at the second term, we've got 2x minus 1. So it's not as easy to see straight away x can't be naught. What we now have to do is to say, well, this entire expression can't be naught, because if that's naught, then we're dividing by 0, which is not allowed. So we say, well, if 2x minus 1 were equal to naught, we do a little linear equation and we solve for x. And we will get that x is equal to a half. So basically, we look for the value of x that will make that expression 0. And the value for x that happens at is a half. So x cannot be equal to a half and x cannot be equal to naught. So these restrictions will help you to streamline your solutions from your equation, so you can see if there's any that needs to be left out. So it's a good idea to always put those restrictions in first. Okay, next step, we are solving an addition of fractional equations. So first step, find an LCD, and here our LCD is going to be x times 2x minus 1. Alright, so we times the first term. Remember, my LCD is x times 2x minus 1, so I times each expression by what it is lacking from your LCD. So the first term, 2x plus 1, I need to times by 2x minus 1. Okay, because that is over just the x. And then I'm going to say plus, I've got 2x over 2x minus 1, so therefore I need to times the 2x by x. Okay, and this is all over my LCD, which is x times 2x minus 1. And then on the other side, we're going to say is equal to 3 times x times 2x minus 1. So now what you'll notice is your entire equation is over the same denominator. So at this point, once you've found your LCD, you can drop your LCD. You no longer need to carry this through, because remember, you've stated your restrictions. X is 0, x is not equal to a half, so therefore we can drop this denominator. We divide it out. Okay, so the next step, we will just be left with the numerator. So we've got 2x plus 1 times 2x minus 1 plus 2x squared is equal to 3x times 2x minus 1. Okay, we then need to simplify that a little bit further. 2x plus 1, 2x minus 1, where have you seen this before? You've got exactly the same terms, one with the plus, one with the minus. It's called a difference of two squares. So in order for me to times this bracket out, I simply square the first term, so I get 4x squared. Square the second term, I get 1, and we separate plus times a minus with a minus. Okay, so we get 4x squared minus 1 for that first term. Or if you don't see the difference of two squares, the expansion for that, you can simply times term by term. Okay, so you can do FOIL, you'll get to the same answer. Plus 2x squared, we just bring that down, is equal to, we're going to times the 3x into the bracket, so 3x times 2x will give me 6x squared minus 3x. Okay, now remember when I showed you guys how you get your standard form of a quadratic equation, it has to be everything on the left hand side is equal to 0. So you want to get it in the form ax squared plus bx plus c is equal to 0. So in other words, we don't want anything on the right hand side. We need to pull everything over to the left hand side. Okay, so if I do that, on the left hand side, simplifying 4x squared plus 2x squared, 6x squared. And I bring the other 6x squared across, I get minus 6x squared minus 1 plus 3x is equal to 0. And what you'll actually see, what happens here is that you get 6x squared minus x squared. So this no longer is a quadratic equation because there's no x squared term to solve for, because it's now being cancelled out. So therefore, you're now left with just a straightforward linear equation. So we've got minus 1 plus 3x is equal to 0. In fact, we could have kept the minus 1 on the other side. So 3x is equal to 1. Therefore, x is equal to a third. Okay, so this one works out quite nicely and worked out in a simple way so that we actually didn't have to factorize the quadratic equation. But what you will notice is when you get to your linear answer of x is equal to a third, if you compare that to your restriction, there's no conflict, because our restriction was x couldn't be 0 and x couldn't be a half, and it isn't either of that. So therefore, the solution, x is equal to a third, is perfectly valid. It's all okay. All right. So guys, with your fractional equations, remember always first set up your restrictions and then find an LCD and take it through, simplify, times everything out. And if you see quadratic expressions in there, as here you saw I had an x squared on either side, take all the terms, take everything over to the left-hand side and then attempt to solve. All right. So the next type of equation we're going to look for, or we're going to look at solving, is simultaneous equations. So here we are asked to solve for the values of x and y, and we are given one equation, 3x plus 2y is equal to 2, and then 6x minus y is equal to 25. So this is what I said to you in the beginning. We have been asked to solve for two letters, x and y. Therefore, we should have two equations. 1, 2. We do. Okay, so then we can carry on. All right, I'm going to try and show you two different methods, depending on time, but I think we should be fine. So I'm going to show you two different methods to solve this simultaneous equation. The one method is called elimination. And then the other method that you've learned or seen is substitution. Okay. In this case, it will turn out that elimination is the better method to use, but it isn't always that way. All right. So what I'm going to do, guys, is we've got this set up as 3x plus y, just rewrite it, is equal to 2. And then we've got 6x minus y is equal to 25. Okay. When we deal with simultaneous equations, we have to call one of the equations equation 1, and then the other equation 2. And then we refer to things in terms of equation 1, equation 2 to help us know what it is we're doing. When you're doing the method of elimination, you're basically eliminating one of the variables. In this case, I hope that you will agree, it is quite easy to see that the variable that we should be eliminating is the y. Because if I add these two equations together, plus y minus y, I'm going to get 0, and then I've eliminated one of the variables. Hence, the name, elimination method. Okay, so for me to eliminate here, I'm going to say equation 1 plus equation 2. Okay, so if I do that, I literally just add down the line, so I add in a vertical manner. 3x plus 9x will give me, 3x plus 6x will give me 9x. Positive y minus y will just give me 0y. Nothing. Nothing's going to be there. 2 plus 25 will give me 27. Therefore, I've got 9x is equal to 27. Divide both sides by 9, and I'll get x is equal to 3. Okay, so I've got the value of x is equal to 3. Now, don't make the mistake of stopping here, because remember, we're solving for two variables, so we still need to go back and find y. So we take this value for x and we can substitute it into either equation, and we often get asked, well, doesn't matter which equation I use. No, just use whichever equation you can easily work with. Okay, so you just judge by the question. They will both give you exactly the same answer if you've made no mistakes. So let's take the first one. I've got 3x plus y is 2. I'm going to substitute x is equal to 3 back into equation 1, right? So I'm going to get 3x, so I replace the x with 3, so 3x plus y is equal to 2. So remember, this was equation 1 that I substituted into. So therefore, I'm going to get 9 plus y is equal to 2. Therefore, y is equal to negative 7. Just take your 9 over to the right-hand side. So therefore, my answer here is x is equal to 3 and y is equal to negative 7. Okay. What you can do, if you like, is take that solution, 3 and minus 7, substitute it into either one of your equations and just test the values to see if it makes sense and it works out. Okay, while we're on this point, before we move on to substitution, I also just want to show you in terms of graphs what's happening here, because we're basically dealing with two straight lines. We've got 3x plus y is equal to 2 and 6x minus y is equal to 25. So all of you have drawn straight lines before, and I want to show you what we actually seeing in terms of the graph when we ask you guys to solve simultaneously. All right. I'm going to draw up a very rough axis. Let's get a little axis going. So there we go. All right, and this is not to scale at all. It's just for illustrative purposes. Okay. And pen. There we go. So we've got 3x plus y is equal to 2. You guys will remember using the y-intercept method or the dual intercept method, or what else would you use? Gradient and y-intercept method to solve or to draw these lines. I'm going to use the dual intercept method. For those of you who don't remember how to do this, don't worry, you will go over graphs again, but it is a section you did in grade 9. So basically what we're going to do is take that line and find out how it cuts the axes, and we're going to just draw a straight line. So I'm going to do it very quickly because, as I say, it is something you guys will cover later on in the year. So 3x plus y is equal to 2. I get my y-intercept there. If I say x is equal to 0, I get my y-intercept is 2. And to get the x-intercept, I say y is equal to 0, and I get x is equal to 2/3. Guys, I am going over it very quickly, but as I said, please don't worry about it because it's really just revision from grade 9, and you will go over this again in detail. Then, the second one, we've got 6x minus y is equal to 25. So if I let x equal 0, I'll get a y-intercept of negative 25. And if I let y be 0, I'll get an x-intercept of 25 over 6. Okay, so that's just slightly more than 4 comma something. All right. Then what I'm going to do is I'm going to take these points and plot them on a line. Remember, all I'm doing here is really just illustrating to you how this whole thing is working. What is this point 3 minus 7? What does it mean? Okay, so my first line, I've got a y-intercept of 2, an x-intercept of 0,66. So y-intercept of 2, x-intercept of 0,66. So it looks something like that. And then with the other line, I've got a y-intercept of negative 25 and an x-intercept of 4, some other digits. So we've got negative 25 and just over 4. Not to scale, just for illustration. So that's sort of what we're looking at, okay? Now, you'll see where the two graphs are intersecting. And let's just see if I can get a nice bright color. Let's use a yellow to show you that. Where the two graphs intersect, at that point, that's the point 3, negative 7. So what it's actually telling you, when we solve two equations simultaneously, we're basically looking for where graphs are intersecting each other, and we're finding the points of intersection. So that's really all we're doing when we say solve simultaneously. We're looking for points of intersections on graphs, and it's just really putting it in terms and in context of things you've learned before. Remember, maths is never learnt in isolation. Every section depends on every other section. Okay, so what we're doing here, when we're solving simultaneously, is finding the point of intersection of, in this case, two straight lines. Okay, all right. So that's the graphical solution to that simultaneous equation. And then very quickly, I want to look at the substitution method. Okay, so we've still got our two equations. We've got 3x, and I can't remember them. I must be having short-term memory loss, Lini. So we've got 3x plus y is equal to 2, and then we've got, I think it's 6x minus y is equal to 25. Let's just double check that. 6x minus y is equal to 25. Great. Okay, so again, so this is now substitution. So I've shown you so far, I've shown you elimination, I've shown you graphical interpretation. Now we're going to look at substitution. We will always get to the same answer, right? as long as we don't make any mistakes. Okay, so I've got the first equation, I'll call it 1. Second equation, I'll call it 2. Okay, as I've shown you before, the quickest way to do this specific sum is actually elimination, but just for illustrating, we're going to use substitution as well. So I'm going to say y is equal to 2 minus 3x, and this comes from equation 1. I'm simply just rewriting in terms of x. So y is equal to 2 minus 3x. I'll call that equation 3. So basically what I've done is I've created a substitute value, if you like, for the value of y. So now I can write my y without having the letter y there. Instead, I can have the letter x, which serves us a better purpose. Okay, so I'm going to take that equation 3 and I'm going to substitute it into equation 2. All right, when you're substituting this into equation 2, there will only be x's left in your equation. So I'm going to have 6x minus y, but now we don't have y anymore. Y is equal to 2 minus 3x, so I replace my y with that. And that was equal to 25. Okay, then we simplify. You can see we've got an equation now just with x in it. So I get 6x minus 2 plus 3x is equal to 25. 6x plus 3x is 9x. Take the 2 over to the right-hand side. 25 plus 2 is 27. So therefore, x is equal to 3. Okay, which it should do because we've already seen by elimination x was equal to 3. I still need the value for y, so I'm going to say substitute x equals 3 into equation 2 this time, just to show you it works regardless. So I'm going to get 6 times 3 minus y is equal to 25. So minus y is equal to 25 minus 18. 6 times 3 is 18. Take it over to the right-hand side. I get negative y is equal to 7. So therefore, y is equal to negative 7. So we get exactly the same answers as we did when we did the method of elimination. You should always get the same answers because it's just two different methods. Okay, but you're still going to get the same point of intersection when we're talking about graphs.
I'm sure you've seen the walk together photo on our page. Please post a caption and like the captions that you think are best. The 3 captions with the most likes will each win a pair of tummy tackies. We'll post the winners on Friday, so get to liking and get all your friends to like too. Now it's time to take a break, so don't go away. We'll be right back. Welcome back from the break. I know you can't wait for the term to end and for the holidays to start. This year we bring you revision sessions from term 1 from the 28th of March till the 6th of April. These will be repeats of all the Learn Extra live shows from term 1. These programs will run from 9 a.m. in the morning till 7 p.m. at night. Go to our website learn.mindset.co.za for all the details. But for now, let's get back to the revision.
We're going to try and improve your skills with some of the questions on inequalities that I have. I think Abraham and them have put that up for you guys. Starting with question 1. So here we are asked to solve for x and illustrate the answer on a number line. All right. So inequalities, guys, it's similar to an equation, to an equality, but obviously the inequalities implies certain other rules that you've got to bear in mind when you're dealing with inequalities. So if you understand equations, linear equations, it's really not a big stretch to move from linear equations to linear inequalities. And many of you have already gone way past this at school, and you're probably thinking, oh, this is so easy, which is great. Okay, so let's look at 1a. We've got x plus x over 3 is less than 11 minus x over 2. Guys, whenever you're faced with denominators and fractions, you need to find an LCD. Here our LCD between 3 and 2 is going to be 6. So we multiply our LCD throughout the inequality. Just like in an equation, once you found your LCD, you can drop it, provided it's not a variable. And in your case, it's not going to be a variable in this section just yet. So LCD is 6. We times through by 6. We're going to get 6x. So I'm timesing the first term by 6. We times the second term by 2, so I'm going to get plus 2x is less than 11 times 6 is 66 minus 3x. Okay, guys, so I'm not putting that step in. All I've done is I've times through by my LCD of 6. Okay, so we got rid of the LCD. All right, we then, like you would in a linear equation, you collect all of your variables onto one side. So 6x plus 2x will give me 8x. Bring the minus 3x across, so it becomes plus 3x is less than 66. So 8x plus 3x will give me 11x is less than 66. Divide both sides by Whoopsie. Divide both sides by x, by 11, not by x. Alright, so divide both sides by 11. So we get x is less than 6. Alright, so we've got x is less than 6 from the inequality that they gave us originally. But remember, you're not done, because they also say illustrate your answer on a number line. So guys, this is a very rough sketch. You don't have to now go and take a ruler and measure 6 units and all of that. You really just, okay, let's see if we can extend this page. There we go. We're really just putting in a rough illustration of x is less than 6 on the number line. So I'm going to say that's 6 there. X is just less than 6. So I use an open dot and show that it's everything to the left of 6. Now that we've gotten to that point, in fact, let me just make that a little bit more clearer. Let's discuss the open circle and the closed circle. So here we're going to have an open circle. So I've got x is less than 6. Now remember, guys, when you're dealing with just a less than or just a greater than, you're not going to have a closed dot when you're representing your solution. So if you look at the number line I've just got x is less than 6, and we just have an open dot above the 6. So at this point, let's just mention that an open dot means not included. Okay, so x was just less than 6. It wasn't equal to 6. And a closed dot would be included solution. So if I had x is less than or equal to 6, we would then have a closed dot above the 6. All right, so your open dots is to show not included solutions, closed dots show included solutions. All right, hopefully you all follow that. Okay, in part B, okay, and I'm going to try and do this with as least amount of mess as possible, because it's a bit of a weird one to try and fit in here so that I can see the whole sum. Again, guys, we've got an LCD here of 16 in this case. So the first step is to get rid of that denominator by multiplying through by 16. So I'm going to do this at the top here and then bring this all down to the bottom. My LCD is 16. I'm going to multiply the 3y by 16. Minus 4y plus 4, we're going to keep that in brackets because we must remember to multiply the negative into the brackets. And on the right-hand side, we're going to multiply by 4. Okay, so my first term is going to become, okay, so I'm going to get 16y minus, I think it was 4y, but as you all know, I'm getting older since yesterday, so let's just double check that. It's going to be minus 4y minus 4 is greater than, let's go back up, and we're going to times the 4 by the 3, so we get 12 into y minus 1. So we're going to multiply that into the brackets, so I get 12y minus 12. Okay, so let's just go back up there. I found an LCD of 16, multiplied the first term by 16, so I get 48y, multiply the negative into the bracket, and then times the 4 into the bracket on the right-hand side. Okay. All right, now that we've got it in this form, we do the same thing as we did before. We collect all of our variables onto one side. 16y minus 4y is 12y. All right, and we're going to get minus 12y is greater than minus 12 plus 4. So I get 12y, is that right? 16y, not 16, made a mistake, that was supposed to be 48. I was wondering what's happening, all my y's are disappearing. 48y minus 4 is going to give me 44. 44 minus 12, there we go, so let's change that. So 48 minus 4 is 44y, minus the 12y that I bring over is greater than minus 12 on the right-hand side. Take the minus 4 over, so it becomes plus 4. Okay, guys, so the mistake I made there was I forgot to multiply the 16 by the 3 to get 48. Okay. Hopefully, and I'm sure, I mean, you guys are so sharp. I'm sure they spotted that, Abraham. Okay, 44 minus 12. I wonder if my old brain can take it. Let's subtract it just to double check. Smart ink. Let's try and close that. Okay. Turn it off. There we go. Let's turn that off. There we go. Let's try again. 44. Would have been quicker to just do this in my head. 44 minus 12 is 32. So we've got 32y is greater than minus 12 plus 4. That gives me minus 8. Divide both sides by 32, and I get y is greater than minus 1 over 4. Because I would get 8 over 32. 8 goes into itself 1 time. 8 goes into 32 4 times. All right, so we end up with y is greater than minus a quarter. Okay, so all the values to the right of minus a quarter. So to put this on a number line, we're going to have minus a quarter there. And it's just greater than, guys. So this is what I was saying. If we don't have an equal to sign, we're going to start with an open dot. It's everything. And how I remember which way, okay, if you don't really get, I mean, if you understand greater than, great. But for those of you that can't understand which way the arrow is supposed to be going and which way the line is supposed to be going, what I always say to my students is, look at the arrow or look at the sign of the inequality. That should be the direction in which your line points. You see? So that's arrow. I keep saying that arrow. This inequality is pointing to the right. That means that my line with my arrowhead needs to point to the right as well. So y is greater than minus a quarter. Okay, so let that be the indication of whether your line and your arrow needs to point to the left or to the right. Okay, that's for those of you who are struggling to understand what the sign is saying. All right, and you don't understand the crocodile thing and that, then this the arrowhead is a nice way for you to remember. Okay, so that's the graphical solution to that inequality. And remember, what I showed you in the beginning of the lesson is when we're dealing with linear inequalities, we're really talking about graphs, linear graphs, and according to the graph, what is happening? What have they asked you for? Is it greater than a number? Is it smaller than a number? You can bring everything back to your linear function, and we're looking at what's happening to the y values around a certain point. Okay, all right. Let's carry on improving our skills. This is now question 2. And here we're going to tackle interval notation. Okay, so let's discuss interval notation before we actually have a look at the question. Now, a lot of you, as soon as you see interval notation, and it's a good thing if you do this, as soon as you see interval notation, you think of interval notation, you think of square brackets and round brackets. Okay? A round bracket implies, let's just take that out. Okay. Alright, so a round bracket really just implies not including that end point. Okay, so a round bracket, very similar to your open dot, it indicates a value that's not included. Your square bracket, very similar to your closed dot. In fact, it's exactly the same thing. It means that that end value is included. So that's including your last point, and that's excluding your last point. Guys, what you need to remember about interval notation as well is because we're talking about a period over a number line, whenever you're giving answers in interval notation, your answers for x or y or whatever variable are spanning that entire period. So what that means is all your answers are going to be real numbers. So, for example, if x is between -2 and 1, we're talking about all the values between -2 and 1. So there you're going to have like a half, you're going to have 3/4, you're going to have all the fractions, everything included in that interval. So as soon as you are asked to do interval notation, you automatically should be realizing that you're dealing with real numbers. If your question then stipulates, like in this question it says x is an element of real numbers, that's fine. But if your question stipulates, for example, x is an element of natural numbers, or x is an element of whole numbers, or x is an element of integers, you can't then give your solution just with your square and round brackets. You then have to give specific values. And I'll show you maybe a little bit with this question what I mean there. Okay. All right, let's have a look at this question. We've got to solve for x. We've got -2x plus 3 greater than equal to -3 less than 11. They tell you x is an element of reals. They tell you you're going to use interval notation, so that's fine. We're looking at all the real values in whatever period we get at the end. First thing, guys, it looks confusing, but you're just going to split it up, right? You're looking at just the inside thing, just the -2x plus 3. We want to get to a point where we're going to have x is less than something, x is greater than equal to something. So we need to strip away everything else that's joined to the x. First thing we're going to do is get rid of the positive 3 by subtracting 3 on both sides. So I get -2x is less than 11 minus 3 is greater than equal to -3 minus 3. So I've taken the 3 away on both sides. When your expression is included inside your inequalities like this, remember, you can't just subtract on the one side. You've got to do it throughout the inequality. So I've got to subtract the value of 3 on the left-hand side as well. Okay. So I'm going to get -6 is less than equal to -2x is less than 8. Okay. We then going to get rid of the -2. Now this is where the summary we did comes into play. When we divide by a negative, we reverse the signs. In this case, we're going to reverse both the signs, the less than and the less than 8 and the greater than -6. Okay. Divide through by -2. Change your signs around. So I'm going to get 3 is greater than or equal to x is greater than -4. Okay, -6 divided by -2 gave me 3. 8 divided by -2 is -4. So I've got 3 is greater than equal to x, which is then greater than -4. Now, a lot of you might get confused at this point because it's not in the way you recognize with both your inequalities facing the left. All right? All you do, guys, is you can rewrite this. So if 3 is greater than equal to x, x is greater than -4, really what we're saying is the solution to x lies between the smallest number and the biggest number. So x is greater than minus 4 and less than equal to 3. So this is the same as that. Okay, that's exactly the same thing. These two things are equivalent. Okay, so x is greater than minus 4 but less than equal to 3. So whenever you're dealing with an inequality, your smaller number is going to be on the left-hand side, your bigger number is going to be on the right-hand side if you have your variables squished in the middle. Okay, so when you're getting your solution at the end, you're going to have, if we're dealing with your inequalities facing to the left. Do you see what I've done there? I've turned them around into something that you guys are more familiar with. You're used to having it with the x in the middle, and then we've got a greater than the smaller number, and then a less than the bigger number. If you're going to do it that way, you can turn any inequality around, make it something that you understand. You just need to remember, if you write it in this way here, you need to have the smaller number on the left-hand side, the bigger number on the right-hand side, and then your x in the middle. Okay, just make sure you don't get confused with those signs there where they're facing to the left, and then those ones where they're facing to the right, because they mean exactly the same thing, but some of you I know can at times get confused with what it's saying to you. Okay, alright, so just be careful with the way you write that out. Alright, so I've rewritten it. It means the exact same thing. X is less than equal to 3, greater than minus 4. They said write this answer in interval notation. So if you give the answer and you finish off there, you're losing some marks, right? Because we need to now write this as x. Whenever we write interval notation, we start with x is an element of, we start from the smallest number, and we're starting at minus 4. So x is an element from minus 4 up to and including 3.
We've come to the end of our show. Thank you so much, Mindsetters, for joining me and for chatting to me during the show. Remember to visit our website, learn.mindset.co.za, to get your notes and to watch the videos from the term. Goodbye.